So let's see what we remember about setting up word problems. You remember now we've done 500,000 of them with, say, rectangles. And please tell me you know how to generally find the area of a rectangle. Length times width. Okay, good. Do you remember consecutive integers? Like if the first one is n, what's the next one? N plus. Okay. If the first one is 5, the next one is 6. So that's 5 plus 1.
No, I didn't mean to say 1.
It is 1. Yeah. 5 plus 1. So if the first one is n, the next integer is n plus 1. Okay, stuff like that. Remember? All right. So, but now we have quadratic functions that we can make use of. You know, with like an x squared or some variable squared, right? So let's look at exercise 1. What shape do we have here? Rectangle. And what do they tell you about the rectangle? The area is 45 square feet. What else do we know? The length is 1 less than twice the what? Width. Okay? And what do they want us to do? Find the dimensions are, find the length and the width. So in part A, they want us to represent the width with what? Capital W, and the length of the capital L, right? So let's write something for length. What would length equal according to the words up there? 1 less than twice the width. W is the width, right? So it's 1 less than something, but 1 less than what is it? Twice the width. The width is 45? Okay, give me an expression here. Length equals what? Well, how do you represent twice the width? The width is W. 2W. And how about 1 less than that? 2W minus 1. So the length is 2W minus 1. Remember doing those? The length is 1 less than a thing. The thing is twice the width. Okay? What do I want to do in part B? Based on area. We know that area is what times what? That's volume. It's just a rectangle, 2 dimensions. It's just width times length times width, or width times length, right? So it'd be W times L, wouldn't it? Yeah. So width times length equals what? 45. But hold on. So that equation I just wrote, what can be substituted in there? That L is equal to what? So I can replace the L with the thing it's equal to, right? So I have W times what? 2W minus 1 equals what? Now I have an equation with 1 variable, right? You can't solve an equation with 2 variables unless you have another equation with the same 2 variables, but right? You feel like what? No, there's not. Well, you're thinking incorrectly. You can work on it. You can ask Mr. Stein, but he'll steer you wrong. Okay, now they want us to do what? Okay, I would normally do it there, right? So what would I do to solve? I'm going to solve it and get the width first, right? So what would I do here? Is this going to be a quadratic, by the way? Yeah. Okay, so what am I going to do with that W? And what do I get? 2W squared minus W equals 45. You don't have to. You can. It's just generally not assume there's one in front. You can. All right. So what do we need to do now? You guys know this. Well, why do I have to subtract 45? Explain that. Why does it have to equal 0? Remember? For some reason you know. Is there a w squared and a w term?
Yeah.
Or like if there's an x squared and an x term in it, what does it have to equal to solve it? 0. So not x's but w. So we have w squared and w. Does it equal 0?
No.
How do we fix that? So if I subtract 45 from both sides, is there a like term over here on the left side with the 45? There's 45 like terms of either of these two things. So it's not going to combine with either one, right? So what do I end up with? Minus w equals 0. There we go. We know how to solve these, don't we? Okay. There's a 2 in front of the w squared. So we should first look for a what? Is there one? No. So what method do we have to use here? You got to use the A times C method, right? What's A? What's C? False. Okay, so 2 times negative 45, everybody, equals what? What is 2 times negative 45? Okay, it's negative 90, right? Because, like, okay. Now, what? I need two numbers at what now?
Multiply to negative 90.
At the same time, add to what? No, negative 1. They got to multiply to negative 90 and also add to negative 1. It should be simple.
Negative 90 and positive 1.
Negative 10 and positive 1, does that equal negative 90? I bet it does. Yeah. What? And what's negative 10 plus 1? Oh, no, that's not right. 9. Yeah, 9. Sorry, not 1. Who said 1? Negative 10 plus 9. Yeah. That's my negative 1. So that works. Amy, remember what I do with these two numbers now for that middle term? This is, let me just fix it, negative 10 times 9, negative 10 plus 9. Is that what you meant? Okay. What do I do with the negative 10 and 9, Amy? Somebody then put that middle term up into not negative 1w, but it's equivalent what? Negative 10w. There you go. So 2w squared minus 10w plus 9w minus 45, right? Equals 0. Factor by grouping. So it's at? No, there's no w on it. There wasn't a w here. It doesn't combine with it. It's not like terms with these. So it just gets tacked on the end. Right? There wasn't a w in it, so I can't just throw it on the end of 45. Okay, factor by grouping. GCF in the first group. 2w, leaving w minus 5. Next group. Plus 9, leaving. There we go. It should start looking the same. Now, what's the common factor? W minus 5, leaving. Equals 0. Still equals 0, right? Okay. Hey, Amy, this factor. What do we do with these two factors? What do I do with the two factors? Set them equal to 0. So we get W minus 5 equals 0, or 2W plus 9 equals 0. What does W equal over here? 5. How about over here? We get 2W equals negative 9 equals negative 9 halves. Now listen, that's a valid answer, right? But this is a real life problem. Is the width going to be some negative number? Right? So everybody listen carefully. When you're in a real world problem, right, most of the time when you get a negative, like for length or something like that, you must disregard it. Okay? Because our width is not going to be negative. Yeah. Where? Here? 2W equals negative 9. Up here, that's plus. Because it's the same as this. It's that vector. Right? You guys get that, right? In a real world problem, you have to cross out, and like on the Regents exam, you have to show that you crossed out the negative. Okay? Well, are we done? And this is in inches, right? We've got the width. What else do we need? How do we find that? Right, the length is 2 times, so the length equals 2 times 5 minus 1. What's the length? 9 inches. Okay? Oh, these are in feet, sorry. That in feet. That should be there. I should read the problem, huh? All right, just check it real quick. What's 9 times 5? And that's the area, right? There you go. Okay. Moving along. What's the shape now? Oh, square. It's like a rectangle, but what? You know what all sides of a square? Yeah, well, the same. The square has a rectangle, by the way. You know that, right? Yeah. Special kind of rectangle. Yeah. Or if the side length is S, it's just S times S, isn't it? The same for S squared, or X squared, right? All right. So what do they want us to do to this square? And what? Yeah, there's more word, right? Okay, so we're adding 2 inches to one side and doing what? Okay. And what's the result of that? A rectangle, area 60. They want the original area of the square, which means we'll have to find the original side length of the square. Let's draw that. We don't know the side length of the square, do we? But what if I call one side X? This side would be what? X squared. Okay? But now they make a rectangle out of this, don't they? By doing what? All right, so up here, instead of X, it's now what? 2? X plus 2. And then here, that way, instead of X, it's what? X minus 2. That's our rectangle. What else they tell us about this rectangle? Area 60. Give me an equation for this. Like, so can we get an equation and solve for X and then come over here and find the area of the square? Is it the same? What's our equation, guys? What? X plus 2 times X minus 2 equals 60. No. Well, first, is this going to be a quadratic? Yeah. And will there be an X squared and an X term if we distribute those two things? All right, so let's get those distributed now. right? I know, like, normally you're like, okay, why can't I just set these both equal to 0? Because what does it not equal?
0.
It does not equal 0, right? So let's distribute through here. What do we get? Distribute twice. What do we minus 2x plus 2x. Hey, this is like a, go ahead. Boys, it'd be nice if we'd have seen something to begin with. Equals 60. 2 times negative 6. This might not have an x term, huh? Hey, guys, is that a plus b times a minus b?
Yeah.
Oh. What happens to these two middle terms? So you get what? Equals 60. Hey, does this need to equal 0 to solve it now?
No.
Why not? It doesn't have an x term. So what can we just do? No, there does. What? Where's the x term? That's x squared. No, there's an x squared. That's an x term. That's an x term. That's an x squared. So what can we do? Since there's no x term, add 4 to both sides. You get what? Well, we just want to do that. We don't need it to equal 0 because there's no x term. So now what do we do to get x from x squared? Take the square root of both sides. Not square it, square root it. And what's the square root of x squared? X equals, technically it's plus or minus 8, right? But we're going to disregard the negative. So it's just x equals what? 8. What's the inches? That's my plus or minus with the minus crossed out. The square won't have a side length of negative 8 inches, right? All right, did we answer the question? Why don't you actually determine what the question is?
What was the area of the
What's the area of the original square? So the area of the square equals what? 8 to the 4th? Yeah, 8 times 8, or 8 squared. So the area, subscript S for square, is what? 64 what? Inches squared. Area is always in square inches. All right, can you follow that? Okay. Let's go over here. Once we can get done here. These are the ones you guys like, number ones. Square is the same, multiply by itself. 8 times 8. Right, length times width, width the same. So it's just 8 squared. Hey, by the way, that's why they call it square. That's what you do to find the area. Square the same. We never put that together. All right, let's look at this one. What do we have? 2 rational numbers. Okay, what's the property? Yeah. Okay. Why don't we start this real simple? What do you want to let stand for the number to begin with? N. Beautiful. So I'm just going to write N equals the number. Okay? Now, usually you have like let N equal whatever. Right? Okay? Well, let's take these one at a time. Instead of like writing out the equation, let's just make some expressions for the things they say. So the product, let's start with the product of 7 less than 3 times the number. What would that be? 7 less than what? What's 3 times the number? 7 less. There's 1. Okay, with 1 more than the number, which would be what? There we go. And it is equal to what? So that would be what? Okay?
Second one.
Really? So what does it say? It says the product of that and that is what? Equals that. So let's write that equation
3n minus 7.
with parentheses, right?
And then in that case, n plus 1 equals 10n.
Okay. Oops, I didn't need the parentheses at the end there. Right. Because I want to get all the, everything broke loose out of there, right? It's probably going to have to equal 0, right? So let's distribute. What do we get? Go ahead, speak. 3n squared plus 3n minus 7n minus 7 equals 10n minus 2.
Hold on, wouldn't it be 4n in the second?
Here?
Yeah.
3n times 1.
Oh,
Now, let's not start getting this, let's combine like terms over here first. Right?
3n
3n squared, what?
minus 4n.
Minus 4n minus 7 equals 10n minus 2. So do we have an n squared and an n term?
Yeah.
What does it have to equal? Does it? It does? After that equal sign, there's a 0?
No.
Okay, it does not, right. What do we do about that? No. Why am I dividing?
Add 2 to the negative 7.
Well, you mean, why not add 2 to both sides of the equation?
Yeah.
Okay, so I just added to the negative, so there. And what about the 10n? Divide. How about subtracting it? And now let's put it under their like terms. They both have like terms to go with, right? What's that leave us?
3n squared minus 14 minus 5 equals 0.
Now it equals 0. Okay.
Cameron's on.
Do it out there. Well, all right. Yeah, it would be horribly inconvenient.
You don't want to drag you down.
In fact, we go right over to Mrs. Petchen's room and let her deal with it. All right, what are we going to do? Factor it. What are we going to look for first? Is there one? What method are we going to have to use? Why? What?
The number.
There's always a number in front.
There's a number greater than 1.
Something other than 1.
Yeah.
Other than 1. Could be negative 2. Yeah. Okay, A times C method.
3 times.
So numbers have to multiply to negative 15 and also at the same time add to what? What numbers multiply to negative 15 and also add to negative 14? Negative 15 times 1. That's negative 15, right? What's negative 15 plus 1? That gets it. Again, I don't need you to do this every time if you're comfortable with it. I suspect you're not. So, okay. Okay, so I'll be nice and lie to you. You'd rather me tell you the truth, wouldn't you? That's when you.
Mr. Barrett told me that it's not nice to tell the truth, but I always got told that telling the truth is better than.
No, he's right. Not always nice, but
Yeah.
better. You're right.
Yeah,
Exactly.
but
Yeah.
Mr. Barrett's is not.
Yeah. Not always. Like if you if your wife asks you if these jeans make me look fat, you better lie. Because you don't want her feeling like she needs to improve.
I'm gonna be honest, I'd probably tell you the truth because.
Guys don't care. Like if you told me these pants make me look fat, I'd get on my like, hey, that doesn't matter to me.
Does it really think I don't care? I don't care.
Well, it's all everything's Venn diagrams, right? There's always overlaps. Anyway,
It's close.
okay. We got to split this middle term up into what, kids?
Negative 15.
So 3n squared, what?
Negative 15.
Minus negative 15?
Or
N plus 1n minus 5 equals 0. Now we, thank you, GCF there. 3n leaving and minus 5, GCF here. It's one that doesn't usually help us, but here it does, leaving us n minus 5 equals 0. Common factor now. Leaving Amy, what do I do with these two factors now? What? Yes, it does. What do we do? God, plus the here we go. Set them equal to 0. So n minus 5 equals 0, or plus 1 equals 0. What's n equal over here? Or 3n equals negative 1. So what does n equal? Divide both sides by 3. What do you say? Just call me large. I know, that was kind of the joke. So there are two numbers. We got the two numbers that meets that criteria. Sweet Salt St. Marie, Fancy Moses. So, just we'll have to finish this tomorrow.